Hey guys, this is Group 4 from New Era University of the Physics Department, and today my groupmates and I are going to talk about heat of vaporization. But before that, first we gotta know what is heat of vaporization. And right now, my classmate is gonna explain to you what is heat of vaporization.
The history of Latin. The English word Latin comes from Latin latens, meaning lying, hidden. The term Latin heat was introduced into calorimeter around 1750 when Joseph Black commissioned by producers of Scotch whiskey in search of ideal quantities of fuel and water for their distilling process to studying system change such as of volume and pressure when the thermodynamic system as well as constants temperature in a thermal bath. James Prescott Joule characterized latent energy as the energy of interaction in a given configuration of particles, i.e., a form of potential energy, and the sensible heat as an energy that is indicated by the thermometer relating the letter of thermal energy. Done.
What is heat of vaporization? The amount of heat necessary to manage of vapor into a liquid at the same temperature is called latent heat of vaporization or the hidden heat of vaporization. When liquid changes to vapor, heat is absorbed, and when the vapor is condensed to liquid, the same amount of heat is liberated. In this experiment, the heat of vaporization of water will be determined by methods of mixtures. Steam at 100 degrees Celsius will be added to water at a temperature of 5 to 10 degrees Celsius. As I mentioned earlier, the method of mixtures, the law of conservation of energy requires X, the heat given up by the steam, be equal to the heat gained by the water. The heat given up by his steam in condensing into water is provided by the following formula, which will be explained by my colleague.
Alright guys, as my groupmate mentioned earlier, to find the latent heat of vaporization, first you need to find the mass of the water, the specific heat of the water, and delta T. And by the way, to find delta T, you need to subtract T final minus T initial. And delta T applies to each one over here since they share the same temperature. In other words, the thermal equilibrium. After that, you add that with the mass of the cup and stir, the specific heat of the cup and stir, which is equivalent to the specific heat of the water, and delta T, minus mass of the cup, stir, and water and steam, specific heat of the steam, and delta T. After that, you divide it by the mass of the steam. And to find the mass of the steam, you need to subtract the mass of the water before and after heating it up. That subtraction is your mass of the steam. And that's pretty much it for the calculations. After you get all the numbers by following the procedure we mentioned earlier, you will just have to plug in the numbers and you'll get your latent heat of vaporization.
Materials: 1 piece calorimeter with stirrer, 1 piece triple beam balance, 1 piece dry rub, 1 piece beaker, 1 piece rubber tubing, 1 piece thermometer C100 degrees Celsius, 1 piece per half pads, 1 piece cubes ice, 1 piece steam generator, and 1 piece stove. Procedure 1. Set up the apparatus as shown. Fill the steam generator about 1/3 full of water and place it in the stove for boiling. Perform this first in order for the water to be heated while doing other tasks. Using the balance, determine the mass of the calorimeter cup and the stirrer record. Fill the and determine the mass of the cup, stirrer, and water record. Note: make sure that all of ice to cold the water are all melted before taking the initial weight of the cup, water, and stirrer.
Place the calorimeter cup with water and stirrer in the calorimeter. Then stir the water and determine the temperature to the nearest tenth of a degree. Record it in the report sheet. When the water in the steam generator starts to boil, steam begins to come out of the rubber tubing. Carefully place the end of the rubber tubing in the inner container of the calorimeter through the hole in the top. Make sure the end of the rubber tubing is submerged so that the steam will bubble through the water already in the cup. The thermometer should also be in the cup while steam is being added.
Step 6. Watch the temperature in the calorimeter. It will go up quiet rapidly as soon as the temperature reaches 45 to 50 degrees Celsius. Remove the rubber tubing. Do not shut off the burner until after the rubber tubing has been removed from the water. Step 7. Stir the mixture carefully, then determine the temperature to the nearest tenth of a degree. This is the final temperature of the mixture. Record in the report sheet. Step 8. Remove the calorimeter cup. Stir and water from the calorimeter housing and determine their total mass. Record in the report sheet. Step 9. Make the necessary calculation to complete report sheet. Thank you.